Well, good morning, everybody. Happy to have you here virtually, or you're in person, and I'm happy to be here virtually through this video. We're going to be going over this section of geometry for area of a sector. So you guys will be able to find the area of a sector if you look over to the sideboard there, and you'll see that. So area of a sector is going to be very similar to what we did with arc length, where arc length we said, okay, well, if we know this entire circumference, we just want part of that. We just want however much of the circle we're dealing with. So we said, okay, well, how much of the circle we're dealing with? We found that out by taking the measure of the arc in degrees, dividing by 360 degrees the total degrees of the circle. So we're doing a very similar concept here today with area of a sector. But first, let's talk about what a sector is. A sector is just a section of a circle bounded by a central angle and its intercepted arc. Think of a sector like a piece of pizza. You guys know I love food, so shocker, shocker, shocker. So the shaded area here is our sector. It's bounded by the central angle, which has x degrees, and the intercepted arc right up here. So area of a sector, like I said, is going to be a portion of the entire area. So the entire area, if we recall, was pi r squared. So I'm going to do this. I'm going to say area, capital A, is equal to, I'm going to do m for the arc measure, just like we did for the degree measure of arc for the arc length, divide that by 360 degrees, so the total of the circle, times by pi r squared. So this formula probably looks very familiar because it's almost identical to the arc length formula. The only difference between this and the arc length formula is arc length, instead of pi r squared, which is the area formula, it uses 2 pi r, or pi diameter, which is the circumference one. So let's go through some problems. So find the area of the shaded sector, round to the nearest hundredth, which is 2 decimal places. So we have this little sector here with a central angle of 51 degrees, we're told. So we plug things in. We say, okay, well, the area is going to be equal to 51 divided by 360 times pi times, well, what's our r? We are told BC is 16 feet long. So 16 being squared. Multiply the entire top together there, and we get 13,056 pi divided by 360. Which leaves the area to be approximately 113.94 square feet. Remember, for area, we use square units. So, set up, multiply, divide, and you're approximating, you're good. Same idea on this next one, but the arc measure is 139 degrees. So, the area of this sector is going to be 139 divided by the total 360 times pi times r being squared, which is 22 being squared. Taylor Swift would be darn proud. So we multiply the top together and we get 67,276 pi divided by 360. I still think of Kevin Malone with the pies from The Office. What's that in salads? It doesn't work. We approximate this to end up being 587.09 square centimeters. On the third one, same idea. Area is 84 degrees for this sector, divided by 360 times pi 3 squared. That means area is, well, 84 times 3 squared, so 9 is 756 pi divided by 360, which gives us our approximate of 6.6 square millimeters. On the next one, this time a little bit of curveball. This sector, the central angle is 126, but the shaded sector then is going to be 360 minus the 126 because it's the rest of the circle over here, okay? So it's going to be 200 and Why am I blinking? 234. Ooh, that green does not show up there very well. Let me change colors. Let's go with orange. That's better. So area of the sector is going to be 234 divided by 360 times pi r squared, so 13 being squared. So area is, if we multiply all of it together, 39,546 pi divided by 360, which gives us an approximate of 345, here we write that, 0.1 square yards. Once again, 345.1 square yards. On to the next couple examples here on 5 and 6 before we flip the page. Same idea as the last problem. This is 42 degrees, so the rest of the circle is 318 degrees. Area of the sector is 318 divided by 360, so the majority of the circle, times pi 9 squared. Now, if you really wanted to, you could, as a matter of fact, find the area of this sector, find the area of the entire circle, and subtract the two, and end up with this area of the shaded region. But that'd be more work. And I'm not a fan of that. But you can. Mathematically, it is a thing. Multiply everything together. Area is 25,758 pi divided by 360, which gives us our approximate of 224.78 square inches. Here, back to a normal one. Area is 115 divided by 360 times pi 28 squared. Multiply together, area is 90,160 pi divided by 360. And approximate now, and you get 786.79 square meters. I'm going to skip example 7 because I feel like all these examples are just way too similar. Example 8, slight curveball, I guess, being that we're not told an angle measurement straight up with numbers, but we're told this is a right angle, meaning it's 90 degrees, which tells us the rest of it then is going to be 270 degrees because they have to add up to 360. So we end up getting area is 270 divided by 360 times pi times 29.5 being squared. Now, if you really wanted to, you could simplify 270 over 360 to 3 over 4, which would just make your number smaller. But since we're using a calculator, it might not matter to you. If we don't simplify, and we just multiply through, we get 234,967.5 pi divided by 360, which approximates to 2,050.48 square miles. I'm going to skip number 9 as well. And on number 10, the only unique part to this is we're told the major part of the circle is 341, meaning this little arc is going to be 19 degrees. So you'd go through the whole thing just with 19 degrees. And I don't feel the need to finish this problem because we have 8 other problems right now where we've done, or 7 other problems where we've done them fully that are really the exact same thing. Slight difference on these because you're seeing multiple areas being shaded. Well, we can tell here on this circle here that on number 11 that this angle GHE, the central angle, is a vertical angle with DHF, meaning they're congruent. So it's 46 degrees. So what you could do is you could do 2 separate problems. What you could do is set up 2 different problems here and say, well, area is 46 divided by 360 times pi 7 squared. and then also add that to another one of doing the same exact thing for the other arc. But what I would rather do is, instead of saying 46 up there, take 46 plus 46, add those two central angles together, and get 92. Because total, we want 92 degrees of this 360 degrees. So it doesn't really have to be separate. We can do it together here. And instead of adding anything, that way you just do one problem. And all we're adjusting then at this point is what number is going on top. What is our arc measure? Well, our arc measure is just going to be the sum of the arc measures we need. So if we multiply through at this point, we end up getting 4,508 pi divided by 360, which approximates to 39.34 square centimeters. 12, same idea. Central angles are vertical angles here in this case, so this one is 113 degrees as well. So our area is, well, 113 plus 113, or doubled if you would prefer, is 226. So we want 226 degrees of the total 360 degrees times pi times 30 being squared. Multiply straight across and let our calculator do some work, and we get, see, 50,850 pi divided by 360. Approximate it. Oh, I shouldn't have done approximates in the last one. That was equal. And we end up getting 443.75 square feet. 13 and 14 are almost identical. The only differences between it is that on 13 and 14, you're not told the actual angle of the shaded region again. You're told a different central angle. But we can find it using linear pairs. Both these problems feature that. So on 13 here, you can say angle DEC, the central angle that we're given, makes a linear pair with both angle BEC or angle AED, which are congruent to each other, being vertical angles. So subtract 180 minus a 143 for either of these angles, and you end up getting the angles to equal 37 degrees each. So once again, that's just really one subtraction problem to find one of them, and the other one's just going to be congruent. From there, you would add up the 37 and 37 together, and you get area to be 74 divided by 360 times pi times 10.4 being squared. Approximate, or excuse me, not approximate, but multiply the top together. 8,003.84 pi divided by 360. Let the calculator do the work as we approximate here, and we get 69.85 square inches. 14 is really the same idea. Just to find the central angle we actually want, we take 180 minus 17, and we say, okay, well, the central angle, either of the two shaded ones, because they're congruent, is 163 degrees. So that means they're both 163 degrees. You add those together, and you end up getting 326 out of 360 degrees there. So you want almost the entire circle. And that's going to be equal to area if you take 326 divided by 360 and multiply by pi times 43 being squared. I don't feel the need to finish off that problem since we've done a ton of others like that. Let's move on to 15 instead. On 15, there's two changes here. One, these arcs that are shaded are not congruent to each other as far as area or arc measurement. One is 58 degrees, the other one is a semicircle. If we notice, JM is a diameter, segment JM is a diameter there. So this is 180 degrees. So for our arc, our area, our arc measure is going to be 180, plus 58, those two measures. So that's going to be 238 out of the 360 degrees. So 238, I'm going to rewrite my 2, out of 360 times pi times r being squared. Now, other little trick here. What is the radius? Well, the radius on this problem is actually 5. If we pay careful attention, it's 5. Oh, and that actually reminds me, I missed that on the last problem, 14. 14, that was a little change that they made as well that I missed. Sorry about that. RS, the diameter is 43, meaning the radius is actually 21.5. And that's something I missed on problem 12 too. So you might have noticed that, and if you did, good work. All the rest of the math was actually still correct. I just wrote down the initial problem wrong. On 12, xy is 30 feet, meaning that the radius is actually half of that 15. But I did still square 15, so the rest of the math on 12 is correct, just so you know. My apologies on that. Back to number 15, though, with the radius of 5, and if we continue to solve, we get the top to multiply to be 5,950 pi divided by 360, which then approximates 51.92 square millimeters. Last but not least, number 16. We're told that this arc is 62 degrees, and we're seeing little congruent things. That's saying that each of these arc measures 62 degrees. So 62 degrees, 62 degrees. So how much of the circle do we actually want? Well, we want 360 minus all of these 62 degrees. So what we want is 360 minus 186. That's going to be 174. So our actual setup is area is equal to 174, area of the sector, 174 divided by 360 times pi times 12 being square, because 12 is the radius. If we multiply the top together, we get area to be 25,056 pi divided by 360. Approximate to finish it off, and it's approximately 218.65 square centimeters. Once again, 218.65 square centimeters. All right, so now the substitute should be passing out the homework section. It'll say Unit 11, Homework 2. This is a one-page document, just so you know. 10 problems, and that is all over what we just did in this video. Once you are done with that, you're done for the day. Next class, we are going to be reviewing for the final, so be ready for that. Otherwise, have a wonderful day, and I will see you when I am back Thursday and Friday.